Good morning students. Today we are going to see Unit 5 Acoustics. Learning objectives are demonstrate the phenomenon of reflection of sound, determine the speed of sound using the method of echo. Now let us revise previous class portion. Longitudinal wave. What is known as longitudinal wave? A wave in which the particles of the medium vibrate along the direction of propagation of the wave. The particles of the medium vibrate along the direction of propagation of a wave is known as longitudinal wave. That is, the particles travel with the wave is known as longitudinal wave. Sound waves based on their frequencies. There are three divisions for the sound waves based on their frequencies. One is audible wave, infrasonic wave, ultrasonic wave. Audible waves ranging between 20 Hz and 20,000 Hz. Infrasonic wave below 20 Hz. Ultrasonic wave greater than 20 kHz. Difference between the sound and light wave. Sound need a medium for its propagation. Light does not need a medium for its propagation. Sound waves are longitudinal waves. Light waves are transverse wave. The wavelength ranges from 1.65 centimeter to 1.65 meter for sound wave, and then the wavelength ranges from 4 into 10 power minus 7 meter to 7 into 10 power minus 7 meter for light wave. And then in sound wave, it travels in air with a speed of about 340 ms minus 1 at normal temperature pressure. Whereas in light wave, it travels in air with a speed of 3 into 10 power 8 ms minus 1. Particle velocity. What is called particle velocity? The velocity with which the particles of the medium vibrate in order to transfer the energy in the form of a wave. The velocity with which the particles of the medium vibrate in order to transfer the energy in the form of a wave. It transfers the energy in form of wave is called particle velocity. What is called wave velocity? The velocity with which the wave travels through a medium. In particle, the particle alone transfers the energy, whereas in the wave velocity, the wave travels in a medium. Factors affecting velocity of sound. In gaseous medium, the factors that affect the velocity of sound are effect of density, effect of temperature, effect of relative humidity. Now let us see the today's class portion, reflection of sound. What is known as reflection of sound? When sound waves travel in a given medium and strike the surface of another medium, they can be bounced back into the first medium. This phenomenon is known as reflection. See this diagram. The sound wave travels in a given medium and strike the surface of another medium, and then they can be bounced back into the first medium. So what is the given medium? Air. That is, the sound wave travels in a air and strike the surface of solid, and then they can be bounced back into the air. So this phenomenon is known as reflection. So here the wave travels from air to solid. A wave travels from air to solid, and then again it bounces back to the air is known as reflection. Now what is known as reflection of sound? The bouncing of sound wave from the interface between two media is termed as the reflection of sound. So see this diagram. The bouncing of sound waves from the interface between two media, air and solid. Here the two media is air and solid. It is termed as the reflection of sound. What is interface? A point where two systems meet and interact. That is, where two medium meet and interact is known as interface. So here the two mediums are air and solid. So the bouncing of sound wave So this is the bouncing wave, the bouncing of sound wave from the interface between two media, interface between the air and solid is termed as reflection of sound. Now what is incident wave? The wave that strike the interface are termed as the incident wave. The wave that strike the interface between the two media, that is the wave that strike between the air and solid is known as incident wave. So here this wave is known as incident wave. And what is called reflected wave? The wave that bounce back are termed as the reflected wave. See this wave, it is known as reflected wave. The wave that bounce back to the air is known as reflected waves. Now from this we have to see what are the laws of reflection of light. Like light waves, sound wave also obeys some fundamental laws of reflection. Now the following two laws of reflection are applicable to sound waves. Now let us see what are these laws. The incident wave, the normal to the reflecting surface, and the reflected wave at a point of incidence lie in the same plane. See this diagram. This is the incident wave and this is the normal, and then this is the reflecting surface. All these three waves lie on the reflecting surface. The incident wave, the normal, and then the reflected wave. All these three lie on the reflecting surface. Here the barrier, it is a reflecting surface. So all these three waves lie on the reflecting surface at the point of incidence, or where all these three rays or meet is called as a point of incidence. So at the point of incidence lie in the same plane. All these three waves lie on the same plane at one point is known as a first law of reflection of light. So the incident wave, the normal to the reflecting surface, and the reflected wave at a point of incidence lie in the same plane. And then second law, the angle of incidence is equal to angle of reflection R. When we measure the angle between the incident ray and the normal ray, it is known as angle of incidence. And then when we measure the angle between the reflected wave and the normal wave, it is known as angle of reflection. So when we measure this angle of I and angle of R, both are same. For example, if the angle of I is 45 degree, means angle of R also 45 degree. Next, from this we have to see what is called incident wave. The sound wave that travel towards the reflecting surface are called the incident wave. Now this wave is called as incident wave. The sound wave travel towards the reflecting surface is called as incident wave. Next, reflected wave. The sound wave bouncing back from the reflecting surface are called reflected wave. The sound wave bouncing back from the reflecting surface are called reflected wave. The point of incidence and then the point of reflection is the same point on the reflecting surface. So here it is the point of incidence, and then the point of reflection also takes place at the same point. All the two rays, that is the incident wave and the reflected wave, meet at one point, and then it is called as point of incidence, and also it is called as point of reflection. So both the point are same on the reflecting surface. So from this, what are called incident wave? The sound wave that travel towards the reflecting surface are called the incident waves. And then what are called reflected waves? The sound waves bouncing back from the reflecting surface are called reflected waves. Now what is called normal? A perpendicular line drawn at the point of incidence is called the normal. We know that this point is called as point of incidence. Now when we draw a line perpendicular to this point of incidence is called normal. What is called angle of incidence? The angle which the incident sound wave makes with the normal is called angle of incidence. So this is the incident wave. So the angle between this incident wave and normal is called angle of incidence. Next, what is called the angle of reflection? The angle between the reflected wave and the normal is called angle of reflection. The angle which the reflected wave makes with the normal is called the angle of reflection. Now, do you know acoustical wonder of Golconda Fort, Hyderabad, Telangana? The clapping portico in Golconda Fort is a series of arches on one side, each smaller than the preceding one. So, a sound wave generated under the dome would get compressed and then bounce back amplified sufficiently to reach a considerable distance. So, it is flourished as a trade center of large diamond known as the Golconda Diamond. This Golconda city and the fortress were built on a granite hill that is 120 meters high, surrounded by massive battlements. Reflection at the boundary of a denser medium. A longitudinal wave travels in a medium in the form of compressions and rarefactions. See this diagram. A region where we have a denser region is called compression, and then where we have a less dense is called as a rarefaction. So, in previous class I told you the denser region is called compression and then rarer region, less dense, is called rarefaction. Here we have more dense, it is called compression. So, a longitudinal wave travel only in the form of compressions and rarefactions. See here, it is compression, rarefaction, compression, rarefaction, compression, rarefaction, and then compression. Suppose a compression traveling in air from left to right reaches a rigid wall. This is a rigid wall. So, here the compression and rarefaction traveling alternatively from left to right, and then it reaches a rigid wall. So, the compression exerts a force F on the rigid wall. So, when they travel alternatively, so at last which one will reach the rigid wall? Compression. So, here the compression produces a force on the rigid wall. In turn, the wall exerts an equal and opposite reaction. So, when we apply a force to any object, that object also applied the force to the another object. So, likewise, when the compression apply a force on a rigid wall, the wall also produces the force. But that force is in equal and opposite reaction. So, equal and opposite reaction means R is equal to minus F on the air molecules. Where it produces the force? On the air molecules. So, this results in a compression near the rigid wall. So, here in the rigid wall, the compression only takes place. So, thus a compression traveling towards the wall is reflected back as a compression. So, when the wall produces the force, again the compression only travel back from the wall. So, the reflected wave also compression. The reflected wave also compression. So, that is the direction of compression is reverse. So, here the see in the second diagram. So, here the reflected wave travel as compression, rarefaction, compression, rarefaction, but it is in the opposite direction. See both the diagram, incident wave is in this direction and reflected wave is in the opposite direction. So, the wall produces the force in the opposite direction. So, R is equal to minus F. This results in a compression near the rigid wall. So, again the wall produces the compression. So, this compression traveling towards the wall is reflected back as a compression. So, the direction of compression is reversed. Now, the reflection at the boundary of a denser medium. Consider a wave traveling in a solid medium striking on the interface between the solid and air. See in this diagram, here also the wave travels, that is longitudinal wave travel as a compression, rarefaction, compression and rarefaction. So, when it reaches a wall, it produces a compression. So, here a wave traveling in a solid medium striking on the interface. Interface means where the two mediums meet. So, here the two medium are solid and air. So, here the compression exerts a force F on the surface of the rarer medium. The compression produces a force F on a rarer medium. As a rarer medium has smaller resistance for any deformation, the surface of separation is pushed backwards. So rarer medium having a very small resistance, so it does not produces any stress or strain. Deformation means it does not change, that is deformation is defined as changing the shape or size or length of an object. So because of the smaller resistance, here the rarer medium does not changes its shape or size or any length. So here the surface of separation is pushed backwards. So here the separation is pushed backwards. So as the particles of the rarer medium are free to move, a rarefaction is produced at the interface. So here the rarefaction is produced due to the interface. As a rarer medium has smaller resistance for any deformation. Here the rarer medium has very small resistance for deformation. So the surface of separation is pushed backwards. So here the separation will push backward. So as the particles present in the rarer medium are very free to move, so here in turn the rarefaction is produced at the interface. So whereas in denser medium compression is produced in turn, but here the rarefaction is produced in which medium? Rarer medium. In rarer medium rarefaction is produced. Thus a compression is reflected as a rarefaction. So the compression reaches the wall and in reflected wave the rarefaction travels. So the compression is reflected as rarefaction and then the rarefaction travels from right to left. More to know what is mean by rarer and denser medium. In previous topic we studied about rarer medium and denser medium. So what is known as rarer medium and what is known as denser medium? The medium in which the velocity of sound increases compared to other medium is called rarer medium. That is when the velocity increases while we compare to the other medium. When we take the two medium, water and air. When we compare the water and air, where the velocity will increase, that is called as a rarer medium. So here the water is rarer compared to air for sound. So which is a rarer medium? Water or air? Water. Water is a rarer medium. So the velocity of sound increases in water. So it is a rarer medium. It is important question in more to know. Page number 63. Mark it. What is mean by rarer medium and denser medium? The medium in which the velocity of sound increases compared to other medium is called rarer medium. While we take the two medium, water and air, which one is rarer medium? Water is the rarer medium. Now, what is known as denser medium? The medium in which the velocity of sound decreases compared to the other medium is called denser medium. Where the velocity of sound decreases, it is called denser medium. So, which one is denser? Air is a denser medium. So, air is denser compared to water for sound. So, very important question. What is mean by rarer and denser medium? In page number 63, mark it. Reflection of sound in plane and curved surface. So when sound waves are reflected from a plane surface, the reflected waves travel in a direction according to the law of reflection. So when we take the plane surface, here the sound wave travel using the law of reflection. We already know the law of reflection. What are the law of reflection? The incident wave, the normal and the reflected wave lie on the same plane, and then the angle of I is equal to angle of R. So when the sound wave travel on a plane surface, it obey the law of reflection. So here the intensity of the reflected wave is neither decreased or increased. So what is the intensity of the incident wave? The same intensity only takes place in the reflected wave. So there is no changes in the intensity of the incident wave and reflected wave while they traveling in a plane surface. While they traveling in a plane surface, there is no any change in the intensity of the reflected wave. Now let us see the reflection of sound in a curved surface. When reflected from a convex surface, the reflected waves are diverged out and the intensity decreased. See this diagram. In a convex surface, the reflected waves diverged out. See the diagram. Here it is diverged out. So here the intensity, what happens? Decreased. In which case? Convex surface. When sound is reflected from a concave surface, the reflected waves are converged and focused at a point. See this diagram. The reflected waves are converged and then focused at a point. So here the intensity of the reflected wave is concentrated at a point. So in a curved surface, when we take a convex surface, the reflected waves are diverged. So here the intensity decreased. When we take a concave surface, the reflected waves are converged. So here the intensity increased. When we take a parabolic surfaces, in parabolic surfaces, it is required to focus the sound at a particular point. So all the rays are focused at a particular point. So in many halls are designed with parabolic reflecting surfaces. In elliptical surfaces, sound from one focus will always be reflected to other focus, no matter where it strikes the wall. In wall, wherever position the waves will strike, it again reflected. So this principle is used in designing whispering halls. In a whispering hall, the speech of a person standing in one focus can be heard clearly by a listener standing at the other focus. In whispering hall, wherever we have to sit, we have to hear a sound of a person. So it is based on this elliptical surfaces. Do you know Whispering Gallery? One of the famous whispering galleries is in St. Paul's Cathedral Church in London. Where is it? In St. Paul's Cathedral Church in London. It is built with elliptically shaped walls. It is elliptical in shape. So when a person is talking at one focus, his voice can be heard distinctly at other focus. It is due to the multiple reflections of sound waves from the curved walls. Why it takes place? Because of the multiple reflection of sound waves. So what is called a whispering gallery? Why the name is given as whispering gallery? It is 30 meters up from ground level and tourists have to climb 257 steps to access to the gallery. It was given its name because a charming quirk in its construction. A charming quirk in its construction. It means that people can whisper against one wall and be heard on the opposite side. Thank you, students.